Time. It's the most familiar of mysteries. We feel its relentless march. Every sunrise, every heartbeat, every tick of the clock reminds us of its passage. Yet when we try to grasp its essence, to truly understand what time is, it slips through our fingers like grains of sand. Is time merely an illusion, a construct of our minds, or is it a fundamental aspect of the universe, woven into the very fabric of reality? Philosophers and scientists have grappled with these questions for centuries. The answers, as we delve deeper into the nature of time, become ever more intriguing and elusive. Imagine for a moment a universe without time, a place where change is impossible, where past, present, and future collapse into a single, unchanging instant. It's a mind-bending concept, and it highlights just how central time is to our experience of the world. But what if we could manipulate time? What if we could speed it up, slow it down, or even reverse its flow? The possibility of time travel, once relegated to the realm of science fiction, has become a tantalizing subject of scientific inquiry. Our everyday experience suggests that time flows in one direction, from the past through the present to the future. We remember yesterday but not tomorrow. We see the effects of causes. This intuitive understanding of time is deeply ingrained. However, physics tells a more complex story. At the most fundamental level, the laws of physics appear to be time-symmetrical. This means they would work equally well if time were running in reverse. So why do we experience time as unidirectional? One possible explanation lies in the concept of entropy. Entropy is a measure of disorder in a system. The second law of thermodynamics states that entropy in a closed system always increases over time. In other words, things tend to become more disordered. Imagine a perfectly ordered deck of cards. If you shuffle the deck, it becomes more disordered. It's highly unlikely that shuffling would ever result in a perfectly ordered deck again. This tendency towards disorder might be what gives time its direction. Our understanding of time underwent a profound transformation in the early 20th century with the work of Albert Einstein. His theory of relativity shattered the Newtonian view of time as absolute and unchanging. Einstein showed that time is relative. It can be stretched and compressed depending on your motion. This effect, known as time dilation, becomes more pronounced at speeds approaching the speed of light. Imagine two identical clocks, one stationary, and one traveling at close to the speed of light. The moving clock would tick slower than the stationary one. This isn't just a theoretical curiosity, it has been experimentally verified. Einstein also revealed the inseparable link between space and time. He showed that they are not separate entities but rather two aspects of a unified space-time continuum. This has profound implications for our understanding of gravity, black holes, and the evolution of the universe. Section 4. Journeys to the future. A matter of speed. If time is relative, does this mean time travel is possible? The answer, surprisingly, is yes, at least for travel to the future. Einstein's theory of relativity suggests that if you could travel at a significant fraction of the speed of light, time would slow down for you relative to someone on Earth. You could return to Earth after what felt like a short trip to find that years, decades, or even centuries had passed. This isn't just a theoretical possibility. Astronauts on the International Space Station, which orbits Earth at high speed, experience a tiny amount of time dilation. Of course, the time difference is minuscule, but it demonstrates the principle. Another way to travel to the future is to spend time near an object with immense gravity, such as a black hole. The extreme gravity of a black hole warps time, causing it to slow down dramatically in its vicinity. Section 5. The thorny path to the past. Paradoxes and possibilities. Traveling to the future, while mind-boggling, seems theoretically plausible. Traveling to the past, however, presents a whole new set of challenges and paradoxes. One of the most famous is the grandfather paradox. Imagine you travel back in time and accidentally kill your grandfather before your father is born. This would prevent your own birth, making it impossible for you to have traveled back in time in the first place. This paradox highlights the potential for logical inconsistencies when considering time travel to the past. It suggests that there might be fundamental laws of physics, yet to be discovered, that prevent such paradoxes from occurring. Some physicists have proposed solutions to the grandfather paradox, such as the idea of parallel universes. Perhaps every time you travel to the past, you create a new timeline or branch off into a parallel universe, leaving the original timeline intact. Section 6. Deciphering time, the language of mathematics. Scientists use a variety of tools to study time, but mathematics is perhaps the most powerful. Mathematical models and equations allow us to describe the behavior of time, even in extreme conditions where our intuition fails. Einstein's theory of relativity, for example, is expressed in the language of mathematics. His equations provide a framework for understanding how time and space are interconnected and how they are affected by gravity and motion. Scientists also use mathematical models to study the nature of time itself. Some models propose that time is not fundamental, but rather emerges from a more fundamental reality. Others suggest that time might be quantized, meaning it exists in discrete units rather than as a continuous flow. Section 7. A timeless question. Time is a fundamental aspect of our existence. It shapes our experiences, defines our memories, and governs the rhythm of the cosmos. Yet despite its familiarity, time remains one of the most profound and enduring mysteries in science and philosophy. We've made great strides in understanding the nature of time, from Einstein's revolutionary theory of relativity to the mind-bending possibilities of time travel. But the more we learn, the more we realize how much we still don't know. So is time travel truly possible, or will it forever remain confined to the realm of science fiction? Only time will tell.